This is lecture number 5 out of 13. And today I'm gonna move into another topic, another one of the capabilities in the field of process mining. This time I'll be talking mostly about conformance checking. So with respect to the outline of the course, we're kind of getting almost to the middle. We have seen all the background about business process management that we needed and performance measurement, and also the topic of automated process discovery, which we covered in the last lesson. And today, I'm going to be talking actually about two capabilities of process mining: conformance checking and variant analysis. So conformance checking has to do with taking a model or a set of business rules and an event log and checking that indeed the process that we have recorded is following those rules or not. And variant analysis has to do with taking two logs and figuring out if these two logs are different, and if they are different, in what ways they are different. And the reason why I'm treating those two topics in a single go is because the variant analysis somehow complements conformance checking. And I'm going to explain you why by going briefly through the typical workflow that I have seen after seeing like dozens of process mining projects. The typical workflow I have seen that the analysts are taking those processes goes as follows. You know, first, when you have managed to put together an event log of a business process, the first thing that you do is to try to discover it using automated process discovery techniques. So for example, if I get a new event log, I will probably want to start looking into what are the tasks in this process, what are the main pathways, is there any rework in this process, is there any repetition in this process, is there any decision points, what are the main decision points? So is that like the first thing that I will try to do. By the same token, I will probably do some sanity checks to see, for example, if there are some cases that are incomplete, which you can see because they have these dotted lines coming out of them. You know, that there are tasks that have dotted lines coming out of them, which means that they are the last task of a case. If I find that there are some tasks like that that have that dotted line, but they shouldn't, because that cannot be the last task of a case, then it probably means I have incomplete cases in my event log, and I'll try to remove them. I will try to understand the structure of the process, the positions of rework, repetition, key decision point, parallel branches. And when I'm done with this phase, depending on the type of project, I might either do a bit of conformance checking, or I might do a bit of conformance mining. It depends on what is important. So if I look at, for example, process mining initiatives in a government sector or in highly regulated industries like banking or telco, particularly when we are talking about backend processes, then we're probably going to do conformance checking more than performance mining. Maybe an exception will be if I am looking at customer-facing processes. Then, even in the government sector or in the telco or banking sector, I'll probably be looking more at performance mining. If I go deeper into the private sector, and I look, for example, into the manufacturing sector, or I look into the pharmacy sector, like the pharmaceutical sector, or even in services industries, and that includes many backend processes in the banking sector or in the telco sector, there is a big drive to be efficient, to deliver high quality and to be efficient. And then I will do more process mining. So there are two profiles of projects in process mining. Some of them are more compliance or conformance checking oriented, and some of them are more performance mining oriented. In both cases, I will first do either a conformance checking or a performance mining analysis. And based on the output of this analysis, I will identify subsets of cases. We call them process variants that I care about, that I need to dig deeper into. And I will then use variant analysis in order to understand these cases. If I am doing conformance checking, then I will use variant analysis to analyze non-compliant cases versus compliant cases. If I am using performance mining, then I will use I will follow that up with variant analysis to understand how the performance differs in my process across different countries, different regions, different types of customers, or different types of products. So in essence, to summarize, conformance checking usually feeds into variant analysis, particularly comparison of non-compliant versus compliant cases. And that is why I'm going to deal with both of these topics today. Let me start by first defining what is conformance checking. Conformance checking is you are given as input the event log representing the executions of the tasks in a business process during a certain period of time, for example, a 1-year period. And you are given a set of business rules, or possibly, in some cases, an entire process model that tells you how this process should normally be executed. And the goal of conformance checking is then to identify what are the differences or the deviations between the event log, which captures what I really do, versus the business rules or the process models, which capture what I should do. In other words, what am I doing that I shouldn't be doing? This conformance checking is the name of the technique. And the main application of conformance checking in the business world is to check for compliance, meaning, am I complying with certain regulations? And that's at the essence, the difference between the term compliance and conformance. Compliance is, do you comply with some external regulations or internally imposed policies at the business level? And conformance is, given that I have captured those regulations as a set of business rules or as a process model that I should follow, are my executions conformant with respect to those rules or with respect to these normative process models? Based on the above, I have seen in my experience 3 types of conformance checking. The first one is rule-based conformance checking. This is what we need to do this is the most typical use case of conformance checking, and it is what we need to do when the regulations or the policies that I need to comply can be easily captured by means of business rules. Like, for example, checking that a given process, in other words, the purpose of rule-based conformance checking is to check that the process is following a set of rules. There is another type of process that happens in very highly regulated industries where I have a process model, a BPMN process model, for example, that captures exactly the sequences of steps that I should be following. And any deviation with respect to this reference process model will be considered to be a potential compliance risk. In such cases, what I need to do is to compare the process model that captures the regulations with the event log, which captures the actual execution of the process. And this type of conformance checking is called model-based conformance checking. Finally, both rule-based conformance checking and model-based conformance checking can only detect deviations with respect to rules or models that have been explicitly captured, but nobody nobody can claim that they have captured all the possible cases of non-conformance in a given system, in a given business system. There are always ways to go around the rules, isn't it? There are always ways, whenever you set up a system, there will be people who will find ways of working around it. And when we are talking about compliance, then people working around, the spirit of your rules can lead to certain risks. And you would like to be able to check, is it possible that some pathways in my process are conformant to all the rules, but there's still something anomalous about them that warrant me taking a closer look at them? And that's what I call exceptional behavior analysis, and it's what I consider to be the third type of conformance checking in the field of process mining. Let me talk about each of these three types of checking briefly. So the first type of check is rule-based conformance checking. In rule-based conformance checking, I have regulations or policies, usually written in natural language, and I'm gonna look at them and translate them into rules. Or we call them also constraints, because they are rules that put some constraints in terms of how your process can be executed. And there are typically three types. This is not a complete classification, but a very typical. Typically, you will find three types of rules. Flow constraints, which tells you that tasks should occur in a certain expected order. SLA constraints, SLA stands for service level agreement, which tells you that between the start of the process and the end of a process, or between the start of a process and somewhere in the middle of the process, no more than X hours should elapse. For example, if a customer sends me a ticket to notify that some equipment is not working, I should be able to respond to that request within, say, 2 hours. That will be an SLA constraint, also known as a performance constraint. And the third type of constraints or rules that we often see in practice are resource constraints, which tells me, for example, that certain tasks can only be performed by certain people. For example, entering an invoice into a system is something that should normally only be done by certain vetted financial officers. In line with the above, I usually recommend to split your rule-based conformance checking into 3 levels. The first, you check at the flow level, then you check at the temporal level. That's where you catch SLA violations or performance violations. And then you check at the resource level. And then to see if you missed anything, you do a bit of an exception analysis to see if there are some exceptions to your rules. Alternatively, sometimes you are very lucky and there is a given process model that must be followed, and you are giving that process model, and conformance checking becomes a little bit simpler because it's basically about comparing your event log against a process model. So that's where model-based conformance checking come into play, and I will be talking a little bit about it. Those 3 levels of conformance checking lead me to a recommended procedure for conformance checking. So step 1 is, of course, I need to go and read all these regulations, and I need to come up with formalize them in the form of rules. I will then define a number of filters in my process mining tools. Typically one filter per rule to capture that rule. And if needed, whenever I find non-compliance cases, I might switch to the perspectives and go into the resource perspective in the process map or in the BPMN model. And that can be very helpful to identify resource constraint violations. And finally, once I have found non-compliance issues, I will try to investigate the impact of this non-compliance in terms of other performance measures, like, for example, cost, processing time, waiting times, or cycle times, among others. I have to further give you like a very structured way of conducting conformance checking, so that you have a given conformance problem and you can map it into process mining operations in a step-by-step manner. I offer to you a conformance checking analysis template that consists of 5 conformance checking tasks that you will typically find in practice. For every task, there is an explanation of, on the left-hand side, what that task is about. And on the right-hand side of the template, there is a step-by-step guide into how to perform that type of conformance checking task. So whenever you jump into you have an analysis task to do as an analyst, and you want to say, like, this is of type conformance, I'm checking conformance of my process against the log, you can go and follow this template step by step. And the rest of the lecture is going to be structured around this template. The first task in this conformance checking template is flow compliance checking. Flow compliance checking can be done initially at the level of the process map. If you want to dig deeper, you have to go into the filters. At the level of the process map, one of the things I usually do is to play around the aggregation metrics that I am displaying on my process map. And I like to move to the maximum and the minimum because they usually tell me a lot about certain types of flow compliance rules. And then if I want to dig deeper, then I will go into the filters. And there is one particular type of filter that is very, very useful in the context of conformance checking, and that is the path filter. So let me move into demo mode, and let me start with the repair example. The first thing I will do for conformance checking is to move the frequency aggregation metric. I will make it maximum. Why? Because that tells me about tasks that are being sometimes skipped. In here, everything kind of looks normal. The application is registered once. The defect is analyzed once per case. The repair and the test repair can be performed multiple times, kind of sounds normal. Archive repair and inform user are performed at most once. Let me now move to the minimum and see if everything looks normal. And I see what? Analyze, register, and analyze defect are performed as a minimum once in every case. That's what mean frequency means. Repair complex test repair are performed in some cases 0 times. And then I say, what? So sometimes I don't test the repair, what's going on, right? Archive repair is performed 0 times sometimes. Informed user is performed 0 times. Well, in this particular case, the reason why this is happening is because clearly there are incomplete cases, as you see. Of an incomplete case. So I'll define a filter to retain only the completed cases, get rid of this data quality issue. This will be, in this case, an attribute filter. And I will say that a case is completed if it has been archived. That's my definition of a case being completed. So I apply it. By the way, I can say this filter and call it filter name is completed cases. And now I only have the cases that have been archived, and I consider those to be completed. And now it looks like it all looks fine. User is informed at least once per case. The repair is the repair is always, the testing of the repair is always performed. The archiving of the repair, of course, is always performed, because that's how I filter this log. These ones are performed sometimes 0 times, but that is normal, because some cases go only through repair simple and not through complex. Some cases go through complex but not through simple, and some cases go through test repair. Same, I will take a process, an event log of a process related to treatment of patients in a hospital. And what will I do to start my conformance checking? I will go to the minimum view. That's a very interesting one. And I see that all patients are registered and all patients go through triage. And I say, oh, some patients, everything else is 0, which means all the other tasks might skipped. Again, this might be a case that some of the cases are incomplete. So I will define a filter with a criterion that captures the fact that a case is completed. In this case, I will say that a case is completed if the patient has been released. So I will apply this filter, and okay, and this now gives me the 74% of cases that are completed. And in here, I see that the process is still the case that one patient didn't go through this task called ER sepsis triage, which means they didn't go through the nurse that classified them into this, that tells them whether or not, what type of treatment they should undergo. And that is a bit of a conformance violation. It's something that violates a rule that normally every patient should be classified before proceeding into a release. And then I can try to figure out why does this happen. So I would like to look into those cases where ER sepsis triage is not executed. So I will right-click, because right-clicking removes the cases where ER sepsis triage occurs and keeps only those where it does not occur. So I right-click, and now you will see ER sepsis triage is not there. This is the case, and actually there is only one such case, as I can see here. This is the one case where ER sepsis triage was not performed. I can see the ID of the case, and I can see what happens to this patient. And it's a very strange case, because the patient did not go through the emergency room registration. They went through emergency room triage and then straight into leukocytes, CRP, lactic acid, etc. So this must be a very special case of a patient who probably was already in the hospital, maybe in another ward, like in the maternity ward or something like that, and all of a sudden they were transferred into a sepsis treatment out from another treatment they were undergoing. Maybe they were going to undergo some other surgery, and then they were moved to the cancer oncology department all of a sudden. And that's why there is no emergency room registration and no emergency room sepsis triage happening for this particular patient. So that's my first step. Now let me go back here and I say, like, there is more that I would like to check. And let me go back to the case frequency. There is more than I would like to check. I would like, for example, to make sure that that in any case, repair complex, in every case, repair complex or repair simple, one of these two occur, right? So because I see that sometimes they're repair complex, sometimes they're repair simple, but I want to make sure that everybody gets repaired. So in that case, what I can do is the following. I will define a filter, and I will try to capture the case that I'm looking for. What is my compliance rule? What is it that I want? I first capture it, and then I'll go into negate it. So what I would like is that every case should go through should either contain the task repair complex or repair simple. By default, this means any value, which means an or. Every case should have this. That's what I want every case to fulfill. And to check for conformance, I'm going to click on remove. That means I am negating the filter. So I'm going to remove those cases where this happens. And what I expect is that I get an empty set of cases. If I get them, which is the case here, the log is empty, then I am happy. There is no case that is violating this criterion. On the other hand, in here, I had a compliance rule, which is that every patient should go through emergency room triage. And when I define the filter, I define a filter to say every case must have an ER sepsis triage activity. And then I negate it. I clicked on remove. I did it with a right click, which is the shortcut, but it's equivalent to having opened the filter and defined this particular filter. So I define my compliance rule, and then I click on remove. I apply, and this time it didn't give me an empty log, but it gave me a log with one case, and that is the violating case. So how is this used in practice? So in practice, what people will do is that they will define this filter, they will save it, and let's call it, for example, no ER sepsis triage. So this is a filter that captures the people who have not gone through an ER sepsis triage. And once I have done that, not only I see those cases in the tool, but it is possible through an API endpoint in a Promore for an external application to ask via a REST call, we call it programmatically, give me all the cases that fulfill this filter. And if there is such a case, that case data is going to be returned back to the external application, and the external application can then do something about it. Like, for example, start an investigation in a given process management system so that we have a closer look at why is it that a patient didn't go through ER sepsis triage. In other words, the analytics tool, which is the process mining tool, will, in there you define your compliance rules, and then other applications can then query the process mining tool to retrieve those cases that are violating certain compliance rules. This is the next thing you will do is to use what we call the path filter in order to find violations of compliance rules that involve a sequence of tasks that need to be performed. In here, it's not going to be very meaningful, but I'm going to show it to you anyways. I'm going to remove all the filters. So I have incomplete cases just for illustration. And I want to capture the fact that after a repair has occurred, whether it is a complex repair or a simple repair, eventually the repair must be tested. How am I going to do that? I'm going to define a filter that where I capture this rule, then I will negate it. So here I will define a path filter, and I will say, in my process, repair simple, if repair simple or repair complex occur, then eventually, so I click here on the eventually follows, eventually the repair must be tested. That's what I want to say. I apply it, and now I see, sorry, I did something wrong. I forgot to that. I define the compliance, a filter for the compliance rule, and then I have to negate it. So I'm going to click on remove. That way I am negating the rule, and I will find those cases, therefore, that I am violating the rule, that negate the rule. So I apply it, and I find that there are two cases where a repair occurs and it is not tested. And here I can see those two cases, the corresponding identifiers, and an external application. If I give a name to this filter, an external application will be able to retrieve them. Okay, so this same path filter that I showed just a minute ago can be used for temporal compliance checking and resource compliance checking. A temporal compliance check usually will involve two activities, and between these two activities, there has to be this amount of time passing by. In some cases, you want to set a temporal compliance rule over the entire case between the start and the end of the case. That should not be done using a compliance path filter, but rather using a performance filter. There is a separate category for it. And there is a third case of temporal compliance checking where it only involves one task. So I'll show you all three of them. Let me take this sepsis log. Let me keep only the completed cases. So those are the completed cases, okay? And I want to capture the fact that between the moment a patient is registered in the emergency room and the moment the patient is classified, that's what triage means, classified, no more than 2 hours should elapse. Or let me make it 1 hour. No more than 1 hour should elapse. So it's not allowed that between this moment and this moment, this happens. And bear in mind that sometimes this activity is not immediately following that one. So I will do this. I will go to the filters and I will create a path filter to capture this rule. So path filter, and I will say the positives, the rule in the positive sense. In the positive sense, between emergency room registration and eventually, not immediately after, but eventually, ER triage should occur. And between these two events, at most 1 hour should elapse. So here in the time interval, I specify upper bound 1 hour. So I'm saying between ER registration and ER triage, regardless of the fact that one follows each other or that there is some other task for whatever reason in the middle, no more than 1 hour should elapse. That's how I define the rule. And now I negate it by clicking on remove, and I will find the cases that violate this rule. I apply, and I find that there are 7 cases that violate my rule, and I can see those cases. If I go here, I will be able to find that, for example, this case violated this rule. The patient with identifier U went through emergency room registration and had to wait a little bit more than an hour to go through. This is a case where ER triage occurred first, which shouldn't be the case. Emergency room only occurred like somewhere in the middle, and guess what? There was no emergency room triage. So in a way, it does violate my rule that there was an emergency room registration somewhere in the middle, like here, but there was no emergency room triage. So each of these cases has something weird in them, just different types of weirdness. Okay, the same type of rule that I defined to you can be used to capture resource constraints. I'll give you a little bit of a contrived example first, and then over time, as the course unfolds, we will be seeing other examples. Let me assume that I want to say that the person who makes the repair and the person who tests the repairs must be two different people, because I want, for quality assurance purposes, that two different people are involved in my case. Just one sec. Small technical issue. So I'm back. So between, I want to say that the person who repairs and the person who tests must be two different people. That's my quality assurance policy says that. So I'm going to try to capture this via a path filter. I'm going to say that when there is a repair, whether it's complex or simple, and later, eventually later, there is a test of that repair, I want that different people, different resources should be involved. The fact that I click here, require that a different resource is involved, means that it shouldn't be, the person who does these tasks on the left must be different from the one who does the task on the right. That's my compliance rule. That's how it should be. So I negate the rule once I have written it, and I will find if it happens. And yes, there are two cases in this event log where analyze defect. So, oh, this is a weird one. Repair complex occurs and is not tested. I have already seen that one. There are two violations of these rules. In this example, they both occur because the repair took place and it was not tested. They do not occur because both tasks occurred, but it occurs because one task occurred and the next one did not occur. The one that should have followed did not occur. So the output I'm getting here is correct, except that I was expecting to have an example where both tasks occurred and they were performed by different people, but this event log does not contain such an example. So to summarize, the path filter allows you to define flow rules, like a given task or one of many tasks should be eventually followed or directly followed by another task. It allows you to define resource constraints, that these two tasks should be performed by the same person, or temporal constraints. Sometimes a compliance rule only involves one activity, in which case you don't need the path filter. You can do it with a simple activity filter. For example, if I wanted to capture here that for example, that test repair should be performed, time frame filter rather. In the time frame, so attribute filter, test repair should be performed by a given resource. For example, test repair should be performed only by one of these three testers. Imagine I wanted to say that, then I would say every test repair must be performed, I pick the secondary attribute, by one of these three testers. I express my rule and I negate it by clicking on remove, and I can see if it's violated. And apparently, yes, there are some cases where the rule is violated. Here is very natural because those are the cases that some other testers perform. But in some cases, I might want to ensure that only certain people are able to perform certain tasks. So I have shown you a little bit hands-on how to use path filters to perform flow compliance checking, temporal compliance checking, and resource compliance checking. Model-based conformance checking means that I am going to take an event log that denotes the actual executions of the process. For example, here I'm showing you on the left-hand side, on the right-hand side, an event log that has a 1, 2, 3, 4, 5, 6 traces. These are the 6 traces. 1, 2, 2, 3, 4, 5, 6 to 6, 1 to 6. The letters in here refer to the little names that I have, the little labels that I have put next to each event and activity. So A, B, C, D, E, H means that my process goes here, then here, then here, D, then E, and then H. So the first trace denote this pathway that I am showing here. And the second trace is a little bit similar, but instead of doing this, I do this, right? And the same thing at the end. So conformance checking means that I give you a process model like that one, and I give you an event log, which denotes a number of executions of the process, and the tool will tell you what is it that you see in the log that you don't see in the model. We call that sometimes unfitting behavior. For example, task C is optional, i.e. it may be skipped in the log. And it can also, a conformance checker can sometimes also offer you the reverse view. What are the pathways in your process model that are never observed in the event log, because that is kind of anomalous that is happening. That particular feature is supported by several process mining tools. Like if you take a tool like Celonis or a tool like Lana, etc., or Signavio, they will have this kind of functionality. In a Promore, it is available as a separate plugin, so you will not find it in the version of a Promore that you are using, but we will not be using that in this course. But I wanted to kind of show you how does model-based conformance checking looks like. So here I have a process model of a loan application handling process, and I just wanted to introduce you to the structure of this process. I check the application form, I return it back to the applicant if it's incomplete, and I do a few loopbacks. Then here I do a number of checks, checking the credit history, appraising the property, assessing if the customer is eligible, rejecting it, or accepting it. And if accepting it, there is a bunch of tasks until completion of the loan. So that is what the process looks like. And this is an event log of that same process, recorded, extracted from an information system. And actually, this is a simulated one, so it's not a real life one. And here I can see how this is performed, and can kind of immediately see that might not be done in exactly the same way I saw before. It might be that it's not done exactly in the same way I do before. I really cannot see it. So a model-based conformance checking tool, what it does is that you give it as input the model and the log. The model is how you want the process to be, and the log is how it actually is. And you can compare them. And so it's gonna, in a way, replay all these traces through the model, and it's gonna tell you that, well, some traces are not fitting as you will expect them to fit. Uh-oh, I did the opposite of what I wanted, which was to enhance. Okay. Not very familiar with this browser, so I don't know how to do it the other way around. Here on the left-hand side, you see differences. Like, for example, here I am seeing a difference. Let me try to reopen this to maybe make it look a little bit better. Compare. Here I see the model, and here I see 4 differences. If I click on one of them, I can see what is the difference about. Let me click on the second one, and it shows me that according to the model, which is in gray, here I should be doing this task and this task in parallel. But there are some traces in the log where apparently I am deviating. The deviation is shown in red. So after this task, I do this task, and then I go straight into this task. And guess what? This task, I don't execute it at all. And that means that I did not check the credit history for some of the customers. Or here, you, after assessing the eligibility, you will prepare an acceptance pack, and you could check if the insurance quote has been requested. You should be doing this according to the model, but red, the log, shows that sometimes you are just skipping that. This means I go in here, then I'm going here, and then I'm going here, and I'm going straight into this one of these two tasks, and these two tasks that are marked in red are not being executed. So that is what a model-based conformance checking tool will show you, like in red, pathways that are not being followed by the model. So if you are given a process model and an event log, you can either discover from the log a model and compare it side by side with the model that you were given as input, or you can use a model-based conformance checking that you will find pretty much in any process mining tool in one form or another. Usually, conformance checking is not the fastest of the operations that a process mining tool does. Automated process discovery turns out to be a little bit simpler, in fact, but you will find this functionality in any process mining tool in one form or another. The last thing I will do for conformance checking is make sure that there are no exceptions that might violate some of the compliance regulations I have in the spirit, but that might not be captured explicitly as conformance rules. There might be some anomalies that I should be investigating, but they follow all the rules that I have encoded as filters. So to do exception analysis, you can use the abstraction mechanisms that automated process discovery gives you. Let me take the sepsis log and let me remove all the filters. And let me put it in the normal view. So this is the normal view of the sepsis log. And I would like to see how does what behavior in this log is rare, highly infrequent, because usually that is where I'm violating certain rules. So I'm gonna click here on the invert ordering. And what I have done now is that this is the full process map. And as I move the slider from right to left, instead of removing the most infrequent behavior, I'm gonna be removing the most frequent behavior, the behavior with the highest case frequency. So let me do that and put it as a minimum. This is the most infrequent behavior in this event log instead of the most frequent behavior. And what do I see? Well, I see a bunch of things. I see immediately that these cases are not starting with ER registration. They are starting with ER triage state away. I am seeing that ER sepsis triage is not being executed after ER triage, but instead I'm doing an intravenous antibiotics and an intravenous liquid treatment. What is more interesting is that I only register the patient in the emergency room after they have undergone an IV antibiotics. And sometimes I am doing like I'm releasing the patient, and immediately after, what do? Admission in non-intensive care, like the patient just went out of the street and a moment later they find themselves in the non-intensive care room. So that is clearly there is some anomaly in that behavior. For each of these arcs, I can always control right click it to retain those cases where that happened. And then I can see exactly the case where this happened here. In here was case with IDBM. And this is exactly what happened to this patient. Started all normal, emergency room registration, triage, but then didn't go through ER sepsis triage until a little bit later. And they were released, and 14 minutes later, they were found in non-intensive care, perhaps due to a mistake. Somebody recorded that they had been released, but maybe they had not been released. So exceptional behavior analysis, as I have illustrated with this example, allows me to find behavior that is probably not compliant in the spirit, but that I might not have captured with the rules that I have encoded explicitly as filters. So after following all these steps, flow compliance checking, temporal compliance checking, resource compliance checking, and exception analysis, you will end up with subsets of cases that are non-compliant. On the other hand, for every rule, you have a set of cases that are compliant. So the manager will say, why is it that we are not complying? Maybe it's actually good. It means that the compliance rule is making people too ineffective, and they are looking for workarounds. So I want to see what is the impact of non-compliance, for example, on the performance of my process. What differentiates those cases that are not compliant from those cases that are compliant? And this question about what differentiates those cases where X happened and those cases where Y happened brings me to the next capability in the field of process mining, is that process mining techniques allows you to analyze, or we can call it compare, multiple variants of a process. And this comparison can be done at different levels, which are captured in this analysis template for variant analysis. The analysis template proposes to you to structure your comparison of multiple process variants into a number of tasks, starting with flow comparison, then frequency comparison, and then bottleneck comparison. This task allows you to take two process variants, not to be confused with case variants. These are process variants, subsets of cases that fulfill different conditions, and to compare them. You can use them to compare slow cases versus fast cases. You can use them to compare cases in Estonia versus cases in Latvia or cases in Russia. You can use it to compare, you can use it in particular to compare compliant cases against non-compliant cases. Variant analysis can be done by comparing the flows between two process variants. And on the right-hand side of this template, you have some guidelines on how to do it. It can be done by comparing, are there some activities that get repeated in one variant that do not get repeated in another variant? Or are there some handoffs that occur in one variant, like resource 1 giving work to resource 2 that are not occurring in the second variant? Or are there differences in the time performance or the place where bottlenecks are located or the way bottlenecks build up in different variants? For each of these two activities, for any of those activities, the first thing that you have to do is to filter cases to construct the event logs of the two variants. And for convenience, you can save the filter logs, and then you can start comparing them either side by side. You put two windows and you compare them, or by means of what we call a multi-log dashboard, or by means of a multi-log log animation, which is what I'm gonna show it to you in a minute. So let me go back to the sepsis example. And I found for example, that there are some cases where the patient is not undergoing an emergency room sepsis triage, right? So I found that. So I am going to then define a filter for that compliance rule, attribute filter. The rule is that every patient should undergo an ER sepsis triage. If I remove this, this only gives me one case. It's not a very nice way of analyzing it. Let me play around rather with the second rule that I had, which is that between the moment, say, a patient goes through the emergency room registration, and let's say the moment the patient goes through the emergency room triage, let me imagine that at most 30 minutes should elapse. That is my objective. That's my target. That's the rule that I want to comply with. So if I remove them, I will obtain the sets of cases. There are about 122 of them that do not comply with my compliance rule. So I will save it and I will say, this is the event log of those cases where ER triage is too slow, violates my compliance rule. I will call it slow ER triage. And on the other hand, I will revert this filter and I will only retain those cases that fulfill this compliance rule. So instead of remove, I'll do retain, everything else the same. And I will save this and call it a normal triage. So those are the cases that fulfill the rule. If I go back to the portal, I will say that there are the slow cases and the normal cases. And I can then go to analyze and view a performance dashboard with both of these cases together. In this case, everything in blue corresponds to the cases that were slow, and everything in red corresponds to the cases that were normal. By the way, maybe I want to change this and do it the other way around. I want to make this one red and this one blue. So that blue means normal and red means not normal. I have to give a name to this dashboard. And then I see a number of charts that compare normal cases against not normal cases. One of the views that is very interesting is the comparison of which tasks happen and how often in the normal cases and in the not normal cases. Let me use a relative scale. In any graph, I can select relative scale to see if there are any differences. And I see that between red cases and blue cases, the frequency, the relative frequency of different activities is pretty much the same, except somewhere here. And what I observed is that among the people where I do a slow triage, there are less of them that come back to for the return to the emergency room later. I can also see that it seems like release C and release D is slightly more, actually 3 times more prevalent in those cases where I do I spend a normal amount of time to triage, and those cases where I spend a fast amount of time. So it seems that the cases that I'm not prioritizing, the cases for which I am violating the compliance rule, appear to be cases where there is less release C and less release D happening. And then I might find, okay, this is natural. Patients who are not critical, who have a release of type C or D, they are the ones for whom I am spending more than 30 minutes in the triage. And I say that that is fair enough. The nurses are doing the right thing. They are probably prioritizing patients that will later get a release A, which are the high priority patients. and the other patients sometimes have to wait more than 30 minutes in the emergency room. So I might find as a manager that that is kind of normal, or I might find that I need to change a little bit my guidelines or my policies, or allocate more resources in the emergency room in order to handle the delays that I am observing. And there are many other charts that we will be seeing next week with performance mining that gives you further insights into the differences between the cases where this is happening, or the compliant cases versus non-compliant cases. There is a bit of a special case of variant analysis where the goal is to compare the cases that happen during one period of time versus the cases that happen during another period of time. For example, those cases that happened in 2011 versus those cases that happened in 2012. In fact, the homework I gave you is in a way a variant analysis exercise where I gave you an event log of an insurance process in 2011 and the event log of the same insurance process in 2012, already split into two separate logs. And the task is to compare these two variants and to come up with a list of differences and possible reasons why one variant performs better than the other variant. Before parting away, I wanted to show you, and I think I forgot, another way of doing a variant analysis, which is by means of multi-log animation. So let me take, this is the full sepsis event log. I'm gonna save it as, I'm gonna put it in BPMN. I'm gonna maybe put a certain, more or less a suitable level of abstraction, say, this is a process model that I kind of more or less understand. I'm going to save it. I'm going to save the BPMN model rather than the log. I'm going to call that sepsis cases process model. I say OK. And now I'm going to go to the portal and see I have a process model of this event log, this one. Just to make sure I open it. This is the process model I just discovered. And I have the cases that are slow and the cases that are normal. I select all three of them, the model and the two logs. And I can now ask the tool to animate these event logs. Animate means that, that I'm going to run at a certain speed all the cases through the process model. Let me grab somewhere in the middle to make it more interesting. And in this way, and I can regulate a little bit the speed. And in this way, I'm going to see if there are differences in the way bottlenecks get built up. There are not that many red cases compared to the blue cases. That's why you don't see many blue dots. But what I see is that there is a case here that gets stuck between admission in non-intensive care and release. And that might be an indication of where bottlenecks are building up in my process. It seems that for the slow cases get stuck in admission NC. Of course, in general, I see red cases flowing a little bit less rapidly than the blue cases, particularly through certain stages of the process, for example, before admission in C and between admission in C and the release A. I also see that most red tokens are going through release C, whereas the blue tokens are also going through the other types of releases that I have here, and not all of them through release C. Okay. This visualization is useful, particularly because you can see the process at different periods of times. And it's kind of important, for example, in business processes where the summer period, June to August, looks different from the winter period, which might be the case in the context of this type of medical processes. So let me close this by giving you a hint of what's coming next week. So this week we saw conformance checking, and we hooked from conformance checking to variant analysis in order to compare compliant with non-compliant variants of a process. Next week, we're going to look at performance mining, analyzing particularly the temporal performance of a process, and then hook that with variant analysis to compare, for example, cases where the performance is better than in other cases. For example, that for a given type of customer, we are performing better than for another type of customer.